Hey there, welcome back to my channel. Today, we're going to be tackling one of the most fascinating topics in physics, quantum mechanics. Now, I know that this subject can be a bit intimidating, but I promise to break it down into 15 simple steps. And if you find this video helpful, don't forget to hit the subscribe button and give it a thumbs up. Step 1. The foundation of quantum mechanics is wave-particle duality. Everything, including particles and light, can behave as both a wave and a particle. Think of it this way: particles like electrons and photons can act like waves, and waves like light and sound can act like particles. It's a bit mind-bending, but it's one of the most fundamental principles of quantum mechanics. Step 2. The uncertainty principle states that the more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. In other words, there's a limit to how precisely we can measure a particle's properties. The act of measuring affects the particle, making it impossible to know both the position and momentum exactly. This is a pretty big deal in quantum mechanics and has some profound implications. Step 3. Entanglement is when two particles become connected in such a way that the state of one particle affects the state of the other particle, regardless of the distance between them. This is where things get really weird. Entanglement is a key feature of quantum mechanics and has been demonstrated in countless experiments. It's as if the particles are communicating with each other instantaneously, faster than the speed of light. Einstein called it spooky action at a distance, and it's still a mystery today. Step 4. Superposition is when a particle exists in multiple states at the same time until it's measured. This is one of the most mind-blowing concepts in quantum mechanics. A particle can be in two places at once or have two different spins simultaneously. It's only when we measure the particle that it collapses into one of those states. This leads us to our next step. Step 5. The Copenhagen interpretation is the most widely accepted interpretation of quantum mechanics and states that particles exist in a state of superposition until they're observed. The Copenhagen interpretation is the standard way of understanding quantum mechanics and has been accepted by most physicists. It says that particles don't have a definite state until they're observed, and the act of observation forces the particle to choose a state. It's a bit weird, but it works. Step 6. Quantum tunneling is when a particle can pass through a barrier that it classically shouldn't be able to. Quantum tunneling is another strange phenomenon in quantum mechanics. It's as if the particle is able to tunnel through a barrier that it wouldn't normally be able to pass through, thanks to the weirdness of quantum mechanics. This has important implications in fields like nanotechnology and quantum computing. Step 7. Quantum entanglement can be used to create unbreakable encryption keys. Remember when we talked about entanglement earlier? Well, it turns out that entangled particles can be used to create encryption keys that are theoretically unbreakable. This has huge implications for cybersecurity and could revolutionize the way we transmit information. Step 8. Quantum computing takes advantage of superposition and entanglement to solve problems that classical computers can't. Quantum computers are a hot topic these days, and for good reason. They take advantage of the strange properties of quantum mechanics to solve problems that classical computers can't. For example, they could be used to quickly factor large numbers, which is crucial for encryption. It's an exciting field that's still in its infancy, but the potential is huge. Step 9. The many worlds interpretation states that every possible outcome of a quantum event actually happens in a parallel universe. The many worlds interpretation is a controversial but fascinating idea in quantum mechanics. It suggests that every possible outcome of a quantum event actually happens in a parallel universe, creating a multiverse of infinite possibilities. It's a mind-bending concept that's still being debated by physicists today. Step 10. Quantum teleportation is a real thing, but it's not quite what you think it is. Quantum teleportation is another concept that sounds like science fiction, but it's actually a real thing. However, it's not quite like the teleportation you see in Star Trek. It involves transferring the quantum state of one particle to another particle at a distance, without physically moving the particle itself. It's a complicated process, but it has important implications in fields like cryptography and quantum computing. Step 11. The Schrödinger's cat thought experiment highlights the weirdness of quantum mechanics. Schrödinger's cat is a famous thought experiment in quantum mechanics that illustrates the strange idea of superposition. It imagines a cat in a box with a radioactive atom that has a 50-50 chance of decaying and killing the cat. According to quantum mechanics, the cat is both alive and dead at the same time until the box is opened and the cat's state is observed. It's a bizarre but thought-provoking concept. Step 12. The double-slit experiment is one of the most famous experiments in quantum mechanics. The double-slit experiment is a classic experiment in quantum mechanics that demonstrates wave-particle duality. It involves shining a beam of light through two slits and observing the interference pattern on a screen behind the slits. The pattern suggests that the light behaves like a wave, even though it's made up of particles. It's a fascinating experiment that still baffles physicists today. Step 13. Quantum mechanics can help explain some of the mysteries of the universe, like the behavior of black holes. Quantum mechanics is not just an abstract field of study, it also has implications for some of the biggest questions in astrophysics. For example, it can help us understand the behavior of black holes, which are some of the most mysterious objects in the universe. By combining quantum mechanics with general relativity, physicists are getting closer to solving some of the biggest mysteries of the cosmos. Step 14. Quantum mechanics is still full of unanswered questions and unsolved mysteries. Despite decades of research, there is still so much we don't understand about quantum mechanics. There are still unanswered questions and unsolved mysteries that keep physicists up at night. But that's what makes it such an exciting field of study. There's always something new to discover, and who knows what breakthroughs are waiting for us in the future. Step 15. Understanding quantum mechanics can change the way you see the world. So there you have it, 15 steps to understanding quantum mechanics. I hope this video has given you a taste of just how weird and wonderful the quantum world can be. It's a fascinating field of study that can change the way you see the world. If you enjoyed this video, please consider subscribing and giving it a like. And if you have any questions or feedback, please leave them in the comments below. Thanks for watching.